Hello, so today we are going to do this problem which is part of Leetcode daily challenge. So flip string to monotone increasing. So the problem says that we get a binary string that is monotone increasing if it consists of zeros first and possibly no zero value, but then it should be followed by ones and possibly no ones. So basically if you have just zeros, 0 0, then this one is valid. If you have just 1, then this one is valid. If it's a combination of 0 and 1, it has to be that zeros are first and then you get the ones after that, right? So that's the idea. And you can flip any place in S from 0 to 1 or from 1 to 0. So you can change the bit from 0 to 1 or 1 to 0. And the goal is to return the number of overall flips to make the string monotonically increasing or monotone increasing, right? So let's take a look at this first example here. So here we can just change this one to 1 and we have an increasing string and we change it only once, so 1. So that's the minimum we can do. Here the minimum we can do is flip this to 1 and this to 1, because if you try to flip all of them to the ones to zeros, that's 3, right? You need to flip 3 of them to 0, right? And so this one is better. Here, if you try to flip these zeros to 1, then it would be 3, right? But instead you could just flip these to zeros, right? So this one to 0 and this one to 0, and that would be all zeros, which is monotonically increasing according to the definition here. No 1, just zeros. And in this case, flipping the ones, we get 2. We do 2 flips, and so we return 2, right? So that's the idea. Yeah, now let's see how we can solve it. Okay, so let's see how we can solve this. So we have for example, let's take a difficult one. I think this one is maybe more difficult, this one. Okay, the third example. So what we want to know is what's the minimum flips we can do to have a monotone. So either all zeros or either all ones, or having zeros first and then having 1 first. Last. And here you could have it empty. You could have only 1 0, or you could have just ones, and you get the idea. So that's sort of the ask. Now, what does it mean to have empty 0 to 1, 0 to multiple, maybe let's say n1 zeros, and then 0 to n2 ones, right? That means there is a certain position here, right, where to the left we have only zeros, and starting from that position we have only ones, right? That's literally what it means. And this can be empty, and so in that case I would be equal to 0, or I can be equal to n minus 1 if there is no value 1 at all. Right? So that's the main, I think, the main intuition there is that we can just count the number of flips we need to do on this division here. So if we do this division where we just need to find the I position where all of these to the left of it are zeros, and then all those to the right are ones, then the problem becomes just, let's check how many flips we need to do here from 1 to 0 and how many flips we need to do here from 0 to 1, right? And the result will be the sum of these two, right? Okay. So this would be the final result, but in the initial string, maybe we had 0 0 and then there is 1 1. And then the rests here are 1 1 with 1 0, right? Then what we will find, so our position I would be here. So what we'll find is, well, in this left side, we need just 1 flip from this 1 to 0, and here we just need 1 flip from this 0 to 1, and the sum is 2. right? But we don't know this I, so how do we find out? Well, let's just try every I, since that would be, if we try every I, then we can just do a linear scan. Now, the only problem becomes, how do we know how many flips we need? Okay, and that's where we can do some pre-processing to see at each position I, how many flips we will need on the left from 1 to 0, and from the going from the right, we can check how many flips we will need from 0 to 1, right? And that should be it pretty much, right? So what's the summary of the idea? Let's run it and then go from there. So let's run it on an example. So we would have, let's run it on this one, on the first example, and then go from there. So the first example was 0, 0, 1, 0, right? So what does it look like on this one? So we'll try I here, but first we want to know for each I how many flips we will need to make from 1 to 0 and from 0 to 1, right? And so let's have two counters first. So we need to have the count for the left, and then we need to have a count for the right, okay? And this will tell us just for every I position. So here for every I positions, how many flips we will need to do up to that point from 1 to 0 to make everything zeros. And here, how many flips from 0 to 1 to make everything ones. Okay, so let's start from the left first for the... So this one is already 0, so we don't need to do anything, right? So for index 0, we need 0 flips from 1 to 0 to make everything to the left 0. And so we move our I pointer to this position I here. Now, how many flips we need from 1 to 0 to make everything 0? Nothing again. So for index 1, 0. So let me just number the indices here. 0, 1, 2, 3, 4. Okay. And so we go again to here. I equal to 2. How many flips? Now we need to flip this 1 to 0. And so for index 2, we need 1 flip, right? To make all this block 0, we need 1 flip for this one, right? And so we move I again here. How many flips we need? Well, we need, for this we can just keep like a counter for ones. That's actually how many flips we need. So we encountered 1, 1. Now we encountered the new 1, so it's 2. So we need 2 flips, right? Now here we chose to make the indices. We need to add 1 so that basically, remember here we said I is the index for the start of the ones, right? And so here let's just make sure we have that working properly. So this one is still 0. 2 is going to be just 0. But 3 to the left of it, we need 1. And let me just move this down. And for 4, how many flips we need? Well, just the 2 before, so 2. Okay, and so that's for the left side. And now we need to do another loop for the right side. And for the right side, we just need to keep track of how many zeros we have. So because we will need all things from I to the end to be ones. So if we encounter 0, we will need to flip it. And so for index 4, right, we have 1, 0, so equal to 1, so we need to flip that 0 to 1, and so 4 is 1. For index 3, well, this is 1, so we don't need to do anything, so it's not a 0, so this is 1. For 2, again 1, nothing, we need nothing, so just 1 because of this one here. So each time we assign just the value at 0. Now we get to, our I gets to, so we are decrementing each time. Our I gets to 1, but this is equal to 0, so we increment the number of 0, and so we assign number of zeros. And then we do 0 again here, and so we assign the number of zeros at this point, and this point the number of zeros is 3, so 3, right? So now we have the count for each left and right. And so the last piece would be just to go through every I and just see the sum, right? So for every I, basically in the range here of the length. So let's say first we try I here. That means the left side is empty, the right side is starting from 0. So basically we want the right side to be all ones. And so to find that out, we just go to this position here, which is 3, right? And so we'll just basically, each time our flips is going to be the min of whatever we found before, and the count of flips we need to do on the left plus the count of flips. So on the left at position I, because that's what we are doing, where we are doing the split, plus the count of flips we are doing on the right. Okay, and so in this case our flips here is going to be just move this down. So at position 0, the left there is nothing, so 0, so that's 0, right? Plus for the right, which is 3, position 0 for the right one is 3, and so it's going to be 3. Okay, and so we advance I and try to break it at this point, which means the zeros are going to be here and the ones are going to be here. So in this case, the zeros is position 1, and so I is position 1, so we have 0. And then for 1, position 1 on the right side, it's going to be 2, right? So 2, so we get 2, so 2 is better, so we remove this and put 2 instead. Okay, and now we advance our I pointer again to here. Now what this means is basically this portion is zeros and this portion is ones. Okay, and so what we'll do here is say go to our count left here. For position 2 it's 0, for right side in position 2 it's 1, and so plus 1, that gives us 1. 1 is better, is smaller, so we use 1 here. Okay, and we advance our I again. Now here this means this side is all zeros and this side is all ones. Okay, and so for this side to be all zeros, 3 is just 1, and for 3 here it's 1 as well. Okay, and so yeah, so this is 2, so it's not better, so we leave it at 1. Okay, and now we try another I, so we advance our I again. Try this I, this means zeros here and then 1 here. Okay, so this will tell us that on the left side it means we are at position 4, so that means we need 2, and for the right side we are at position 4, so that means we need 1, and so we can see it's 3, so it's not better, and so the best result we can find is 1. Okay, and yeah, that's actually the solution. So you can see why it works, because we try every position where even with the empty list of zeros and the empty list of ones, the last one is the empty list of ones, so we try every possible up to the end, every possible case where the left are zeros, the right are ones, and then we just pick the min. But what will help us to make this linear is the pre-processing, where we fill the count left and the count right. We fill the count left by going to the left on the string and just each time seeing how many ones we have, because we will need to flip those to zeros, and then going also on the right and seeing each time how many zeros we have, because we will need to flip those to ones, right? And that's pretty much the idea here for this solution. Yeah, so I hope that was clear. Now, in terms of time complexity, the solution, we are doing just this linear scan at the end, and we are doing 2 linear scans, one for the count left and one for the count right. But each of them is going to be O of n time. Now, in terms of space, we are using these extra collections, so it's going to be O of n space as well. Yeah, so that's pretty much it. Let's code it up and make sure it passes. Okay, so for the solution, we of course need first the length of the string, and then we need our count left, which is going to be how many, so basically count left is going to be how many we have, right, for each position. And then we need a similar one for the right side. And then for first we do the traversal to fill left. And so to do that, we just go from left to right. And for each, we want to keep track of the number of zeros because that's the number of ones, sorry, because the left, for the count left, it's counting how many flips. So how many flips? From 1 to 0, ending before I, right? And this here is counting how many flips from 0 to 1, because we want, remember, this means basically we want left side to be all zeros. And this means we want right side to be all ones. Okay? So how many flips from 0 to 1, so that it's 1, starting at I, right? And ending at the end of the array, at the end of the string. Okay? So 1 starts as 0, and every time we encounter a 1, right, we want to increase the number of ones we have, but we also want to fill count left here with the number of ones. Now, why did we do it before incrementing here? Because of this. It's ending before I, because we want everything before I to be zeros, everything starting at I to be 1. Okay? And so that's what we do here for the one side. And then we are going to calculate the count right, and that's going to be how many flips from 0 to 1. So the count of zeros. And so since we are going from the right, we want to go in reverse order. So starting from the last position to the first position, and each time decrementing. And so again, here, if we encounter a 0, we want to record it. So zeros is +1 here. And here we want to set the count right for I to be equal to the number of zeros, right? So you may say, why did I do it here as well and not here? Well, this is because we want the last position to count as if there is nothing to the right, because we want to have a case where there is all zeros, right? A case like this where there are all zeros. We do want that case to be accounted for. Okay, so now that we have that, now we are going to just try the split at every position in the string. And so basically that would be count left, right, of I plus count right of I. This will give us the total number of flips that we are going to do. But we need to keep track so that we can get the min. And so we start with a really high value here, and just we take the min, because we try every split and see which one gives us the minimum number of flips. So here we return the best value. And that should be it. So it looks like it passes test cases. Let's submit. And that passes as well, right? Yeah, so that's pretty much the idea of this solution. Very straightforward, just trying all the possible splits. But this pre-processing allows us to do it in oven time, so that we don't need to each time maybe count the number of zeros to the left for maybe, let's say, S of I, something like this. So instead of doing this, we do this counting thing here. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.